Jai Hind to all. I am Shivpratap Singh, Assistant Professor, Department of Computer Science Engineering, Akgec Engineering College. Today, our topic of discussion in Big Data, Apache Pig. The course we are covering is Big Data BCS 061 and Unit 5, and topic is Apache Pig. So let's start with what is Apache Pig and why there is a need of Apache Pig and different aspects of Apache Pig. So first we have to introduce about the Apache Pig. So it is basically a high-level data flow platform, or we can say a tool for executing MapReduce programs of Hadoop. So we have to execute MapReduce program of Hadoop with the help of this high-level data flow platform developed by Yahoo, and the language that used here in Pig is Pig Latin. So the language is Pig Latin, developed by Yahoo, and a high-level data flow platform. The Pig scripts are generally internally converted into the MapReduce job and get executed on the data stored in HDFS. Apart from that, Apache Pig can also execute its job in Apache Tej and Apache Spark, different tools. Next, Pig can handle any type of data. So any type of data can be handled by Pig. It can be structured data, it can be unstructured data, or it can be semi-structured data. Structured data, as we all aware about this, data in the form of rows and column, RDBMS structured data, a data semi-structured, we can say it's a JSON file or it's a XML file is called a semi-structured data, or any unstructured data in any other format, or a text file or any kind of word file, whatever it is, that is unstructured data. So Pig can handle any type of data, structured, unstructured, or semi-structured, and stores the corresponding result into the Hadoop file system. So basically the result will be stored in Hadoop file system, HDFS, and every task which can be achieved using Pig can also be achieved using Java used in MapReduce. So we can execute Java programs also, or we can use Pig commands, or we can say Pig Latin language we can use for programming in the Pig. These are the features of Apache Pig. Some of the features of Pig are ease of programming, optimizing opportunities, extensibility, flexibility, and inbuilt operators. So these are the 5 features of Apache Pig. With the help of these features, we can scale our code, we can optimize our scripts, and we can easily program, or we can write complex Java programs for MapReduce via quite easily. So these are the features of Apache Pig. Then types of execution modes of Apache Pig. So we have basically run our Apache Pig in basically these 2 modes. First one is our local mode, and second one is our MapReduce mode. In the local mode, all the files are installed and run from your local host and local file system. So all the files, those are installed and hosted in our local file system or local host. There is no need of Hadoop system, and this mode is generally used for testing purpose. So for testing purpose, we basically use this local mode, and with the help of this Pig command local, we can execute local mode. Also we have a MapReduce mode. In this MapReduce mode, we load and process data that exists in the Hadoop file system. So that the data that exists in the Hadoop file system, HDFS, so we can using Apache, we can execute that data. In this mode, whenever we execute the Pig Latin statement to process the data, a MapReduce job is invoked in the backend to perform a particular operation on the data that exists in the HDFS. So basically, data that exists in the HDFS that will be invoked with the help of these Pig statements or Pig Latin commands. We can use this command, Pig MapReduce, for executing MapReduce mode. Then we have three types of execution mechanism in the Apache. First one is interactive mode or grunt mode. Second one is batch mode, or we can say script mode. And third one is embedded mode or UDF mode. In the case of interactive mode, the pig is executed in the grunt cell. We will discuss it later in this section. Grunt cell. So the pig is executed on the grunt cell. To invoke the grunt cell, run the pig command. And once the grunt mode executes, we can provide big Latin statements and command interactively at the command line. So we can execute with the help of this command. We can active interactive mode or grunt shell mode. Second one is our batch mode or our script mode. In this mode, we can run a script file having a .pig extension. So the files that is stored in pig is having a pig extension. So we can run a script in the file with having a pig extension, and these files contains pig Latin commands. So we can run these files, and these are the pig Latin commands contains in this file with the extension of .pig. And then last one is our embedded mode or UDF mode. We can say it's a user defined functions mode, in which we can define our own functions. We can define our own functions in this mode, and we use programming language like Java and Python. As we all are aware about that, the Latin language commands will execute on JRE, Java runtime environment. So Java is the backend language, so it helps Java. So embedded mode. So we have three Apache big execution mechanism: interactive mode, batch mode, and embedded mode. Then what are the advantages of pig? So we have these three advantages of pig. First one is less number of codes. So pig consumes less line of codes to perform any operation. Reusability. The pig code is flexible enough to reuse again. We can reuse the pig code. And the nested data types. The pig provides a useful concept of nested data types like tuples, bags, and maps. What are these bags, tuples? We will discuss later. So these are the few advantages of a pig: less code, reusability, and nested data types. Then we have architecture of Apache pig. So this is the basic flow of Apache pig. This is the architecture. So the flow of pig. So pig Latin is used to express data flow. So Latin basically is a language of pig used to express data flows. So pig is used to express data flows. First one. Second, execution environment. So local execution in a single JVM, Java virtual machine. So local execution in a single JVM execution environment. Then we have flow of data. So we have UDF, user defined functions, present in local file system. So we cannot directly execute our user defined functions. Those are presented in local file system. We need a script or a language. So we use pig script to execute these user defined functions. We cannot directly execute these user defined functions. So we need help from pig Latin. So user defined functions take help from pig Latin, or convert these user defined functions into a pig script. And the pig script will goes to pig compiler. So pig compiler basically compiles what? Compiles a script and taken input as a input file present in HDFS. So the compiler takes input from a input file and execute operations that are written in pig script. And as we discussed earlier, this compiler will produces a map reduced job. So all operations, all scripts internally converted into map reduced job. So these scripts via compiler will automatically convert it into produces or converted into the map reduced job. So it will give us a jobs. and execution of map-reduce job internally done. And finally, we will get an output file that will be stored in HDFS. So this is the whole flow of execution of a file. File will come through this. This is the input file, and finally all these goes to pig compiler, and the compiler produces a map-reduce job, and finally we will have a output file that will be stored in HDFS. This is basically architecture or the flow of input file applying scripting, pig script. Next, we have components of Apache pig. What are the components of Apache pig, or we can say this is also a architecture. So components of Apache pig. So pig Latin scripts. So we have scripts written in pig Latin. So we have scripts written in pig Latin. So we have pig Latin scripts goes to, and these pig Latin scripts will goes to grunt cell. Grunt cell will provide an interactive environment where the scripts can be written and the scripts will be executed. So this is the grunt cell where we write our pig Latin scripts. And after writing our scripts in the grunt cell, these scripts will be goes to parser. The first component, parser. The working of this parser is to check the syntax of the scripts. It checks the syntax of the script. What is the syntax of the scripts? It checks type checking of the script, and other miscellaneous checks will be performed here in parser. And the main component or the main and the output of this parser will be a directed acyclic graph, or we can say DAG. So directed acyclic graph will be the output of this parser. A directed acyclic graph is a graph that is directed and it doesn't contain any cycle. So acyclic means no cycle, directed means it is having a direction, and it's a graph. We can understand it with the help of example like we have a job J1 and we have a job J2, a job J3, a job J4, and a job J5 and a job J6. So the job of parser is to check the syntax, type checking, and generate an output that will be a DAG. So this will be a directed graph and not having any cycle. So it will be, we have job 1, job 2, job 3, job 4, job 5, job 6. So this is a flow of, or we can say it's a logical plan of execution of scripts. So we can understand with this with the help of this example. So a directed acyclic graph, output of this parser. So it will give us a DAG as a output from the parser, and it represents directed acyclic graph. It represents the pig Latin statements and logical operators. And in the case of DAG, the logical operators of the scripts are represented as the nodes. So these nodes are having logical operators and data flow represented as ages. So these are the data flow. So we have two components in a graph, nodes and ages. Nodes represents the logical operators and the ages represent as data flows. So the output of parser will be a DAG, or we can say a logical plan. So this is a logical plan, how the data will be executed. Then we have optimizer. The directed cycle graph will be passed to this optimizer that carries out the logical optimization. So it will perform the optimizer, as a name implements. It will optimize our logical plan. So optimization task will be happened here. So it carries out the logical optimizations like projection and push downs. These kind of such few example like projection and push down will be happen to optimize this directed acyclic graph. So optimization of this logical plan or DAG will be happened here. So it will optimize our DAG. It optimize our DAG, optimizer. Then we have a compiler. The next components, the compiler. It compiles the optimized logical plan. So the logical plan that will be the output of this optimizer will be compiled by the compiler into a series of map reduce job. So it will give a series of map reduce job. So series of map reduce job will be the output of this compiler. So we have parser first. The task is to checking of syntax, type checking, and generate a directed acyclic graph. A graph that is directed acyclic graph, a graph also called a logical plan, and a graph that contains two information. First one is the logical operators via nodes, and second one is data flow via edges. Optimizer to optimize this directed acyclic graph, and the compiler to compile and to generate a series of map reduce job. So the output will be a map reduce job. So these job will be the output of this compiler. Then we have execution engine here. So the map reduce jobs are submitted to Hadoop in a sorted order. Finally, the map reduce jobs are executed on Hadoop, producing the desired result. So these map reduce jobs will convert into finally the map reduce, and finally this will be the output of HDFS file, will be the output of this map reduce. So all these steps will be the intermediate step, and finally the output of these all steps to convert a map reduce job. So the output is map reduce jobs, and we can also have an output with the help of map reduce also. So in the case of piglatin, we are having more intermediary steps as compared to implementing or converting a file into MapReduce. Then we have few supporting points with the piglatin. So this is the piglatin data model. What is the data model of pig? The pig data model is fully nested, and it allows complex non-atomic data types such as maps and tuples. So non-atomic data types we also have here. So these are the diagrammatically representation of piglatin's data model. So we have atom, we have tuple, we have bag, we have map, and we have relation. So we have these 5 types of data models in pig Latin: item, tuple, bag, MapReduce, and a relation. Now, considering first one, atom. Atom, what is atom? Any single value in pig Latin, irrespective of their data types, is known as atom. So any single value, no data type, nothing else, is called a atom. Stored as a string and can be used as a string and numbers like integer, float, double, characters. In one word, we can say a piece of data or simple atomic value is known as a field. So we have a field in the case of RDBMS, we have an atom in the case of pig Latin. So this is an example. Any name, suppose we have name Raza, and anything 30, we have 30, irrespective of data types. We have these value atom. Then we have tuple, a record that is formed by an ordered set of fields. By an ordered set of fields is known as tuple. So a record that is formed by an ordered set of fields. So these are the fields. This is also a field, two different fields. And if we arrange these fields together in an order, so this is called as a tuple. As a tuple in RDBMS, we have here also tuple. Ordered set of fields is called a tuple. Then we have a bag, third one, third data model of pig. Unordered set of tuples, unordered set of tuples is called a bag. So we have a tuple here, rather 30. Another tuple, a Muhammad 45. So these all are unordered. A bag is an unordered set of tuples, like a bag where we can put items without arranging these items. So we can say it's a bag. No items, only a collection of tuples is called a bag. Similar to a table in RDBMS, like we have a table in RDBMS, we can say it's a bag in the case of pig Latin. And unlike RDBMS, it is not necessary that every tuple contains the same number of fields or that the fields in the same position have the same type. So this is a constant in the case of pig Latin. Next, we have a map, or we can say a data map is a set of key value pairs. In the case of MapReduce, we have key value pairs. So map is a set of key value pairs, and the key must be of type like character array and should be unique. A key should be unique. In RDBMS, the key should be unique. Is here, key should be unique. And the value might be of any type. So key needs to be of type character array. So there is a constant. The key is of type character array and should be unique. So key should be unique and value can be anything. And is represented by brackets. So here we have a key having name, a key with having a name is, and we have value here with respect to key name, we have a value Raja, and with respect to key is, we have value 30. And last data model is a relation. A relation is a bag of tuples, a bag of tuples. The relation in pig Latin are unordered. So relation are unordered in the case of pig Latin. So these 5 are the pig Latin data models. First one is atom, second one is tuple, third is bag, fourth one is map, and fifth one is relation. Now we will conclude here with the differences, a tabular difference between these two, Apache MapReduce and Apache Pig. So we also have Apache MapReduce, the older one, and we have Apache Pig, also used to convert pig Latin scripts into MapReduce job. We have Apache Pig. So why there is a difference or there is a need of Apache Pig? The task is already converted into MapReduce job, and that task or that work is already done by Apache MapReduce. So this is the tabular difference. Why the need of Apache Pig and what are the limitations in Apache MapReduce? First one, a low-level data processing tool, Apache MapReduce, low level. Apache Pig, high-level data flow tool. MapReduce, it's required to develop complex programs using Java or Python. So we only have options like Java or Python. And there, in the case of Apache Pig, there is no requirement or no need of to develop complex programs. In the case of MapReduce, it is difficult to perform data operations in MapReduce. So we don't need to perform data operations or complex data operations is difficult to manage in the case of MapReduce. And Apache Pig provides built-in operators like union, sorting, and ordering to perform data operations. So we have built-in operators, no need to develop complex programs, high-level data flow language. So we can reuse the programs if the language is having high level. Last, Apache MapReduce doesn't allow nested data types. So there is no it doesn't allow nested data types in the case of Apache MapReduce. And in the case of Apache Pig, it provides nested data types like tuple, bag, and maps. So here we are concluding with Apache MapReduce and Apache Pig. So in last 1 minute, we will conclude whatever we have covered from starting. So what is Pig? High-level language by Yahoo. Scripting language is Pig script. Then we have 2 modes, local modes, MapReduce mode. We have execution mechanism, interactive mode, batch mode, embedded mode. We have advantage like less code, reusability, nested data types, and the flow of data via user-defined functions goes to or take helps from Pig script, and the compiler takes input and a Pig script and produces a MapReduce job, and these MapReduce jobs are executed or execution of these MapReduce jobs internally to generate an output file that will be stored in HDFS. Then we have components, or this is the architecture and the components of this Apache Pig. We have parser to generate a directed acyclic graph. We have an optimizer to optimize this directed acyclic graph. We have a compiler. Finally, we have a compiler to compile this logical plan into a series of MapReduce jobs. So these all are the components of Apache Pig. And last, we have these 5 data models: atom, tuple, bag, map, and relation. And the difference, why there is a need of Apache Pig and what are the limitations of Apache MapReduce. So we are here to study this Apache Pig, or there is a need to integrate Apache Pig to convert input data into HDFS. Thank you. Thank you very much.